Guys, today we're going to be looking at a different way that they could possibly ask us to solve inequalities in one variable. So in this case, it tells us consider the inequality 2x plus 5 is less than or equal to 3x plus 1. And they're asking us which value of x is a solution to the inequality. So at this point, we know that when we substitute a value into the inequality here, right? If it's a true statement, then that means that we have found a solution. So we can, in theory, right, substitute each of these solutions that they're giving us into the values of x here, right? And then solve and see if it gives us a true statement, right? However, the other way we could do it is by actually doing this algebraically. So if we do 2x plus 5 is less than or equal to 3x plus 1 here, right? So in this case, we could send the variables to the left-hand side of this inequality symbol, right? And that would, we could do minus 3x because that's the inverse of positive 3x here. So that gives us 2x minus 3x, that's negative 1x plus 5 is less than or equal to 1. In this case, we could now move the constants to the other side. So take the inverse of positive 5 to both sides. And we get negative 1x is less than or equal to 1 minus 5 is negative 4. And here, right, we divide by negative 1. But we have to remember that when we divide or multiply by a negative, this inequality symbol actually flips. So it would do, instead of being less than or equal to, it will be greater than or equal to here. And now negative 4 divided by negative 1, that gives us positive 4. So in this case, right, could be x has to be either greater than or equal to 4. So in this case, if I now look at my answer choices, A is saying that x would be equal to 2. Well, in this case, x is not greater than or equal to 4. So therefore, that is not a possible solution. In this case, now we have B, which is x is equal to 4. So in this case, x is not greater than 4, but it is equal to it, right? So in this case, we should have a solution in this case of B, which x is equal to 4. Here we have x is equal to negative 4. Well, in this case, x, if x is negative 4 is not greater than 4, right? So that wouldn't be an answer choice. And then same thing with x is equal to negative 2. Negative 2 will be less than 4 in this case, right? And so the other way, again, we said we should substitute the values. And in this case, we should be able to check our work. In this case, we could do, well, 2, instead of having x's, right, I could substitute the value of 4. So I'll have 2 times 4 plus 5 is less than or equal to 3 times 4 plus 1. Well, we have 2 times 4, that gives us 8 plus 5 is less than or equal to 3 times 4 is 12 plus 1. And I get 8 plus 5 is 13 is less than or equal to 13. So in this case, we could see that this is true, right? In this case, 13 is not less than 13, but it is equal to it. So therefore, that would be true. So that's how we could figure that out. In this case, now we're looking at a different inequality, right? It looks a little more complex, but same thing. We could either, if you were in a test, you could substitute each of these values for these x's, simplify, and then see if it gives you a true statement. But I'm first going to try to do this algebraically. So if I have 2x plus 4 over 8 is less than x over 2 plus 3, right? So in this case, the first thing I'm going to do is get rid of this 8 down here in the denominator. So the way I do that is by multiplying 8 to every single one of these terms, right? So times 8 times 8. So now these cancel, and all I have is 2x plus 4 is less than, well, 8 times x is just 8x. This is to divide it by 2 plus 8 times 3 here is 24, right? So we have 2x plus 4. In this case here, we could simplify this. 8x divided by 2. This case, it was still less than. Those 8x divided by 2, sorry, is 4x plus 24, right? Because 8 divided by 2 here gives us 4. And there was an x, so 4x. Now we send all the variables to one side. In this case, I'm going to move the 4x to the left. by taking the inverse. So I get 2x minus 4x is negative 2x plus 4 is less than 24. Now I'm going to extend the constants or the numbers by themselves to the other side. So I take the inverse of positive 4. I have negative 2x is less than 20 in this case, right? Remember, here we're going to have to divide by a negative. So in this case, we're going to have to flip the symbol. So x has to be actually greater than negative 10, right? Because 20 divided by negative 2 is negative 10 here. So the value has to be greater than negative 10, right? It cannot be equal to, it has to be greater than. So in this case, if I look at the first one, it says x is equal to negative 10. So this one wouldn't be an answer because it's not greater than that. Then we have x is equal to negative 12. Well, actually, negative 12 is a bigger negative, right? So that means it's a lower value of x. So in this case, that would be false. Now we have x is equal to negative 20. So in this case, again, we have a greater negative value. So that's not it. So that means that in this case, we have that x has to be greater than negative 10. The only value here that will make that true would be that x is equal to 10. And again, I could substitute that into these values, and this should give me a true statement. So let's prove that. So we have 2 times 10 plus 4 divided by 8 is less than 10 over 2 plus 3. Well, here we have 2 times 10. 2 times 10, right? And then now we have 2 times 10 is 20 plus 4 over 8 is less than 10 divided by 2 is 5 plus 3. Here we get 24 divided by 8 is less than 5 plus 3 is 8. 24 divided by 8 gives us 3. So it says that 3 is less than 8. And in this case, again, that is true, right? 3 is less than 8. So we could confirm that the value of x being 10 would actually be a solution to this inequality. Hope that helps. Do expect something like this on a test. And there's different ways that they could ask this question. This is just another way. Hope this helps.